break it down, it doesn't look that bad.
Okay, let's see what we have here.
Here you go.
Some of the questions, you don't have to do much in the way of calculation, but you have to understand the theory of bend allowance. Like, here's a good example, the length of flat A. Well, the finished dimensions for the part is 4. What did you have to subtract out of that in order to get the unbent section?
Sets.
You had to subtract setback. So to get this dimension, you'd have to subtract the setback to figure out what the unbent section is. So from 4 inches, they tell you what the setback, how it's calculated. It's a 90-degree bend, so it's radius plus the thickness, right?
Yep.
So the radius is 3/16 of an inch and the thickness is 0.625. So if you subtract out 3/16 and 0.625 from 4, it'll tell you what the finished, or what the length of that flat happens to be. So if you do that, it should work out to 3.75 inches. Here's another one. The amount of material required to make the 90-degree bend. Well, they don't give you the empirical formula for bend allowance, they give you the geometric formula. But if you follow this formula, 2 pi and then quantity radius plus 1/2 t divided by 4, it'll give you the amount of material required to complete the bend that we call bend allowance. So if we do that, 3.43 inches, okay? What's the length of flat A? Same thing as the first problem that I showed you. In order to figure it out, what would you have to subtract? Setback, okay. What's the flat layout dimension? Well, through process of elimination, you can figure out what the answer is. The finished dimensions are, in this case, it would be what, 7 inches?
No.
3 plus 4 is 7, right, for the finished dimensions? So you know that this can't be right. It's gonna have to be one of these two. So you'll have to figure out what the developed width is. So you're gonna have to subtract out the setbacks and add the bend allowance. So this is one of the problems that you'll have to physically work out to solve. Okay. So if you work it out, it works out to 6.8 inches. Here's another previous test question. Okay. They want you to figure out, it says, what's the flat layout dimensions? Again, the sum of it is going to be 7 inches for the finished dimensions. The developed width can't be 7 inches. So again, you can work it out, and it's going to be one of the other 3 answers. Works out to 6.6. Length of flat A, same idea. Okay. We'll talk about this when we talk about hand form when you come back from break. Closed angle of 15 has to be bent through how many degrees?
165.
Okay. 165 plus 15 is how much?
180.
What's the answer? Why do we try to bend as much as possible 90 degrees to the grain? Why?
So it doesn't
Well, uniform strength. No guarantees if you bend with the grain, But when we bend against it, generally you'll have a better bend because you've got more uniformity in that bend. You've got a piece of material that measures, let's say, 40 thousandths thick, that looks like this, and it's got a 1/2 inch radius. You've got another piece of material that, same dimensions, but it's got a 1/8 inch radius. Which one of those two parts is gonna require the most amount of material?
The
The one with the smaller radius. So this is gonna require more material to make. You had to push the material deeper into the corner in order to make that part. So if you're trying to hold dimensions, let's say 4 inches by 3, you had to push it into a deeper pocket, so that means that it's gonna require more material to make it, correct? When we were trying to locate that neutral axis, the part that isn't affected by bend or tension or compression, about how far is it from inside of the sheet?
Is it C?
So what's the answer to the question?
C.
One
What do you
half.
think? That would give you, not B, alpha, yeah. You have to have 1/2 the material thickness of the bend radius. It'll get you to where the neutral axis is located. How is the radius of a bend measured? Is it the outside of the part or the inside of the part?
Inside.
Okay. Sharpest bend that we can make in a part without critically weakening it is termed what?
And the
Maximum radius of bend.
Minimum or maximum? Minimum. What do you need to know to make a layout?
C. Radius, thickness, and degree of bend.
Okay. That's all the stuff you need to know to do the empirical formula anyway. The curvature is referred to as what?
And the line.
It's not written the way that I would write it, but pick the best answer. It's really the arc. What are they referring to?
Oh, bend.
The radius, yeah. I think that's it for that. They've given you the dimensions, all you have to do is figure out, you know, what the dimensions are for the flats. So, for example, you've got a finished dimension of 1 inch, 2 inches, and 1.5 inch. From that first flat, you're gonna have to subtract out a setback, right? From the middle flat, you're gonna have to subtract out what? Two
Two
setbacks.
setbacks.
And then from the last flat, last flat, you're gonna have to subtract out one additional setback. Dimension D would be the developed width. So again, you have to work out the problem to figure out how much material is required for the entire park. Where is the sight line located in Bending?
One radius from the
One radius from the hidden bend tangent line, right? So the correct answer is what? Alpha, Bravo, or Charlie? You have to figure out the developed width. Fortunately, they've done the homework for you, so all you have to do is figure out what to do with those numbers. So again, just subtract out the setbacks and you have the bend allowances, and you should come out with, that is the answer. You got one bend, how many setbacks do you have? How many setbacks do you have?
Two.
How many setbacks do you have? Two. So what's the correct answer?
B.
Okay. This you should already know already.
C.
Most aircraft sheet metal, how do we get the strength out of aircraft sheet metal?
Heat treatment.
Heat treatment. Okay.
It's 2024.
Okay. All right. What questions do you have? In the lab tomorrow, where I would expect that you're at, I would expect that you're working on a box beam spar at this point, close to finishing the box beam. So, I'll be looking for that probably tomorrow night.